All right, let's dive into a really pivotal moment in computing history, the story of Exadata. We're going to unpack how one single brilliant idea managed to break a rule that had held back technology for decades, and in the process, killed one of the most stubborn bottlenecks out there. For the longest time, it didn't matter how fast we made computers, how powerful the processors got. There was this one single, unshakable law that held everything back. It was this universal truth that basically put a hard ceiling on performance. And that brings us right here to the unbreakable bottleneck. This whole era, it really wasn't defined by speed. It was defined by waiting, specifically what was known as the I/O wait. So what exactly is the I/O bottleneck? Well, here's a way to think about it. Imagine you have a genius chef, that's your CPU, who can cook unbelievably fast, but they have to get every single ingredient from a pantry that's at the end of this super long, narrow hallway. So it doesn't matter how fast that chef is, right? They're always stuck just waiting for ingredients. That's the I/O bottleneck in a nutshell. And this, right here, this was that iron rule. You could have the most powerful processor in the world, a true super brain, but all that potential was just completely choked off by the physical speed limit of those old spinning disks that held all the data. The brain was always, always waiting on the pantry. You know what's wild is just how inefficient this old system was. The CPU would ask for something specific, like, hey, show me all the sales from California in May. But the disk, well, the disk wasn't smart. It would just ship over a colossal data dump of all sales from everywhere for all time. And that poor CPU then had to sort through terabytes of mostly useless information just to find the few bits it actually needed. Of course the connection was always clogged. But what if you could just break that rule? Well, that leads us right to our next chapter, the Smart Scan solution. And this wasn't just a little improvement. This was a complete rewrite of the fundamental rules for how databases even worked. And the key thing to get here is that the solution wasn't about building a wider hallway to that pantry. No, it was about building a smarter pantry. This was a total rethink of the whole relationship between the brain and the storage. And this is it. This is the core idea. Smart Scan. Instead of making the CPU do all the heavy lifting and all the thinking, Exadata actually gave intelligence to the storage itself. It moved the filtering, the sifting, the processing right next to where the data actually lived. So this just completely flips the old model on its head. Now the CPU's request, with all its specific details like California and May, it gets sent directly to the storage. And the intelligent drives, they do the filtering right there. They find only the rows and columns that match, and they send back just that tiny, super relevant slice of data. All of a sudden, that hallway is wide open. The results of this change were, well, they were staggering. Which brings us to our third part, a revolution in performance. That bottleneck wasn't just widened a little bit. It was completely shattered. And this just lays it out so clearly. We went from literally waiting hours for a query to finish, with terabytes of data just flooding the network and totally overwhelming the CPU, to getting results back in minutes, or even seconds. The CPU was finally free to do what it does best, actual computation, not just boring, mundane sorting. This quote really says it all, doesn't it? We are not talking about a 10 or 20% improvement. This was a 1,000-fold leap in performance. It unlocked real-time analytics and data-driven decisions that were just impossible for businesses before. It was a genuine game changer. So let's just quickly recap the impact here. Pushing SQL processing down to the storage layer absolutely crushed the I/O bottleneck. This whole idea kicked off a brand new era for Oracle called engineered systems, where the hardware and software were designed together from the ground up for max performance. And most importantly, it laid the foundation for what was coming next. Because that breakthrough, it paved the way for the next big evolution, going from smart to autonomous. The journey didn't just stop with making things go faster. See, once you solve the speed problem, a whole new question pops up. What else can you automate? What other heavy lifting can you take off of human operators? And this is the answer: the autonomous database. It's built on that same incredibly high-performance Exadata foundation, but it's a system that basically runs itself. It handles its own security patching, it recovers from failures, it tunes its own performance, all without a human having to step in. Now just think about what this means for a database administrator, a DBA.
That really complex, time-consuming art of manual performance tuning, creating indexes, managing memory caches, all that stuff, it was now being handled by the machine itself. The entire role of the DBA was about to fundamentally change.
So the journey is really clear when you lay it out like this. We started in the bottleneck era, where powerful CPUs were just stuck, waiting on slow disks. Then, the smart scan revolution made storage intelligent, and that shattered the barrier. And that breakthrough is what ultimately paved the way for this autonomous future, where the database itself takes over the heavy lifting.
And this leaves us with a really fascinating question to think about. When the machine tunes itself, what new possibilities open up for the people who used to do all that work? What's the next great frontier for managing our data?